So again, the only rule we have in equations, there's only one rule, and that is what we do to one side, we have to do to the other. Okay, we have to keep it balanced. Okay, so that is the only rule we have. As long as we do that, we're allowed to do whatever we want. Okay, now, but the goal is obviously we want to try to solve for the x. So the golden rule is useful when we're trying to deal with rational equations. So let's just review the property that we're going to use. We can multiply both sides of the equation or divide both sides by the same amount. So if I take half of this side and half of this side here, it's going to stay balanced. So instead of 2 bricks balancing 3 ones, 3 circles plus 18, we can say that 1 brick balances 3 circles plus 9 ones. Okay, and we can also do this. We can take, some decimal values here. So if I have 0.7x equals 1 plus 0.2y, I don't really like the decimal, so I'm just going to multiply this by 10, and I get 7. Multiply this by 10, I get 10. I multiply this by 10, I get 2. And as long as I made both sides the same proportion larger by a factor of 10, it's still going to balance. And again, that's the only rule. So we want to be able to use this rule, and we can use this rule to be able to get rid of fractions. So when we have a rational equation, really lots of people don't like that fraction in here. Okay, now I don't mind it so much, but for the most part it is easier to deal with equations that don't have this divide by 4. So how can I get rid of this divide by 4? Well, I don't want 1/4 of a circle. I hate thinking of 1/4 of a circle. It's really kind of hard to do. With 1/4 of a circle balances 5, what I can say is, well, I can just make this 4 times bigger and make this circle whole. Okay, and that's what I've done here. So instead of dealing with a quarter circle, let's just make this side whole. As long as we balance the other side, make both sides 4 times bigger, it's going to be perfectly fine. In this case, we end up being able to solve for x and say that 1 whole x is going to balance 20. Yeah, if a quarter of x balances 5, 5, that means 5, 10, 15, 20. Yeah, one circle is going to be equal to 20. So this is what we can do. Now we can, balance and do the -5, -5 and all that. But some people like to do, and this is what I do, I tend to get rid of that divide by 2. So I'm not really a big fan of having that fraction in my equation. And a fraction really is just divide. Well, if I want to get rid of that divide, I can get rid of it by times. As long as I times both sides by the same amount, I'm going to stay balanced and everything's going to be okay. So when I multiply both sides by 2 here, what ends up happening is, instead of getting half an x, I have 1 whole x. As long as I make everything twice as big, okay, that should be perfectly fine. I'm going to get a whole x plus 10 plus 24 is going to equal. And then if I want to solve this, now it's a little bit easier to solve. I'm not distracted by that fraction. Okay, so I get 1x is equal to 14. Okay, and I can check it. 14 divided by 2 plus 5 is 12. Yeah, that's true. So the rule I'm using, or the property I'm using, is this idea that I can multiply the left side and right side by the same amount. And that what multiplying the whole equation does, it allows me to get rid of the divide or the fraction. So this is